Okay, continuing about our torque tool training, we went over the power head itself and how it clips into the low profile link. You've got your uniswivel on here, which is to get your hoses out of the way so that you don't break off the fittings. It's not a handle and it's not a rigging point. You don't want to rest your hand on it. Now the X-Driver system has other attachments to it that we're going to go over. So I'm going to release the power head from the ratcheting cartridge. And should you be in a situation where the standard thickness of this ratchet link is too thick to fit into a certain area or an overhead height situation, we make what's called the M-Drive. The M-Drive is a cartridge. You can keep the tool still hooked up to the same hose that you have. It's going to clip into the front of this, just like it did on the ratcheting cartridge. It will clip into the M-Drive. And then you have hyper low profile ratcheting cartridges. They'll only fit in one way, through the grooves in the back here. This is going to fit in and it's just going to click forward. Once it clicks in, then you're fully engaged. You're going to want to cycle this tool just like you did the ratcheting cartridge before you apply it to the application. This M-Drive has a couple different attachments you can stick to it. This one is a low profile or a hyper low profile ratcheting cartridge, and if we take this out, you can see they also make a hammer wrench attachment. It's much smaller radius from point to radius and thinner all the way around. It's going to function on the same way as it did. You clip the tool in, you take your non-ratcheting cartridge, and it clicks in the same way. Now you have a super low profile application. Now while this one won't ratchet, you can still put a breakout torque or a final torque onto the application. And the way that this one functions is you're going to hit the button, the piston's going to come out and turn it, and then you shut the pump off, pick the tool up, let it reset, and then stick it back on the application. So we have ratcheting and non-ratcheting hyper low profile cartridges for the M-Drive itself. When you're using the M-Drive, the same situation is going to occur. You have the same power head, so everything about the uniswivel remains the same. This is your reaction area. It goes on one nut and it reacts on the next nut. The only thing with the M-Drive that you need to be cognizant of is the grooves that are inside of here. That is a wearable item on this tool. You can take a rag and you can clean them out, but you need to apply a never-seize or anti-seize inside that groove line to be in compliance with the warranty of the tool. That is a wearable item and it needs to be maintained on the inside of these grooves where that cartridge goes back and forth. So we have the A-Drive, then we have the M-Drive, and the third tool on here I want to show you guys about is what's called the V-Drive. This is a square drive attachment to the X-Driver system. The same power head, even hooked up to the same hoses that you have. You can take the power head and clip it in, and now we have, in this case, a 3/4 inch square drive, 1,400 foot-pound tool that runs off the same X-Driver power head, and you can use a multitude of different sockets that you own in conjunction with the V-Drive. On the V-Drive, same as the other ones. The power head is still the same. The uniswivel, how you release the tool from the cartridge itself, how you remove the tool from the power head remains the same. Clicks in. And this reaction arm on the bottom has a multi-axis base on it. So you can push this up, this will spin around in any direction that you want, and then slide down in the direction that you want. So you want the reaction arm sticking out the same direction as the square drive is. Just like on the low profile tool, this is the front of the tool as you're looking at it. If the drive sticks out the right, it's going to tighten, left it's going to loosen. If the drive sticks out, if you're set up as it is right now to tighten and we want to loosen, you simply take the square drive and push it through. If the drive sticks out the right, it's going to tighten. If it sticks out the left, you're going to loosen. If you'd like to switch the direction from a tightening motion to a loosening motion, you can simply take the square drive, push it through to the other side, and now you can see that the reaction arm is no longer in the same direction. So we want to take this reaction arm, switch it around, and now we're set up to tighten or loosen. This reaction arm is fully adjustable up. You can react in the throat of the tool or out. And now we're back to tighten again. So this tool is going to go on one nut, and it's going to react at the base of this on the next nut as it's going around the flange. If there's not a nut there, you can switch the switch the square drive or the reaction arm to stick out to react against a pipe or an abutment. But in any case, the reaction on a hydraulic torque wrench needs to abut firmly and not move. When you're using this tool, it will butt up against the next nut. It'll true itself up and it'll just start torquing the nut down. If at any point you think it's going to come off or it's going to pry off, that probably means that your reaction point is not very stable. Make sure you have a clean and clear abutment for this reaction arm. This is the way that it's designed to be used. The resistance from the socket to the nut and the reaction are in the same plane. Now let's talk just a second about the sockets that you're going to use. This is a forged socket, a one-piece forged socket. There are two different kinds of sockets in this world. There's casted sockets and forged sockets. If you were to x-ray a casted socket, there's air bubbles in it. A casted socket would be like a chrome socket you might use on a Craftsman wrench. You don't want to use that type of socket on these bolting equipment or hydraulic wrenches because they have 2 and 3 times the equivalent output of an impact wrench or a manual wrench. A casted socket has the air bubbles in it, as I said, and if it breaks, it can actually shatter. You do not want to use a chrome or casted cheap socket on a high-performance, high-pressure hydraulic torque wrench system like this. You want to use a good quality impact socket that's a one-piece forged version. So when you look at the sockets, if they're all wallered out from being hit with an impact wrench, or the square drive is wallered out where it might look like an inverted diamond, you want to go and get another socket. You want to take the square drive from this tool and use all 4 sides of it equally amongst the 4 sides in the socket. If the socket is wallered out, then the square drive is going to hit on 4 pressure points. Make sure you have good quality sockets. When you put it on the tool, it's not loose, it stays on there, and when you put it on the application, you don't physically have to hold it with your hands because of a sloppy socket. A sloppy socket would make the tool hang down and your hands are going to have to be there. So for safety reasons, make sure you have a good quality impact socket that you're using.